Okay, are you guys ready? Can we start? Okay, so today we continue our revision and today we focus on chapter 6. So what we're going to do today is that I will try to do a little bit of summary, and then after that we try to do at least one question or one example, and then after that you can continue your works and try to finish up all the questions. Can you guys hear me clearly or any trouble?
Boleh sir.
Okay, so if you're looking at the tutorial book and your formula sheet, you will see that this chapter, the equation cover from equation 54 until equation 56, 65. So that's lots of equations. But the good news is that all the equation is pretty simple. You can straightforward use the equation. So basically, for me personally, if you are given the questions, you can basically divide into two different types of questions. One, when it involves time, so I'm going to write this one as time dependence. Okay. Another one is about the circuit itself. So the circuit one, maybe I'm going to write in new page. So the difference between time dependent and the circuit is that obviously time dependent, they ask you to find time or they give you time. So got time lah. I'm not going to write that one. Sometimes instead of giving specific time, they might give you a graph. Okay, so this is an example of graph for voltage against time. Okay, let's see if they give you a graph, this kind of graph. What kind of information you can take from the graph? Information apa yang kamu boleh ambil? Kalau dekat sini dia punya apa? Over here,
Sign graph tu sir.
sign graph. Yang ni maklumat apa dekat atas bukit ni?
Voltage.
Yes, voltage apa?
What?
Ha?
Binot
Apa?
ke sir?
Apa?
Binot ke?
Binat betul. So dia adalah binat. Okay, dia adalah peak lah, maximum voltage to amplitude. And then yang merah tu, what does this one present?
T besar sir.
Okay, T besar means this one is a period. So if you have the period, what value that you can calculate? Kalau kamu the period, boleh kira apa?
Frequency?
Yes, correct. You can calculate frequency, which is 1 over period. And then once you get the frequency, you can use the values of frequency to calculate omega, which is 2 pi f. Okay, all of these values you can use, and then you can write the general equation. You can substitute inside the general equation. We have B equals to V naught sine omega t, and at the same time we have I equals to I naught sine omega t. So if they give you this graph, you can basically continue to write this equation. Okay. Alternatively, they might give you this equation and they might ask you to draw the graph, or they might ask you to take out all the information from here. So from omega, you can take the frequency, you can get V naught. From the V naught, you can get the VRMS and so on. And then at the same time, you have the relation between VRMS with V naught, which is equal to square root of 2. And the same goes for IRMS. Okay, so this graph, it could be V against T, or it could be I against T. And then sometimes you might have a shifted graph. Okay, if you have a shifted graph, means that you have plus phi over here. The plus phi here represent phase angle. Okay, it's actually the angle between current and voltage. So angle apa sebenarnya? So if you guys still remember, we have a phasor diagram. Ingat tak phasor diagram? The phasor diagram is basically a vector diagram lah. So example, if voltage is leading the current by pi over 2, this is the example. That means this is my VRMS and this is my current IRMS. Okay, so this is your phi. In this case, phi is equals to pi over 2, where VRMS leads current IRMS lah, by pi over 2. Kenapa dia lead? Sebab dia punya direction is like this. This is the direction of omega. That means this one sampai dulu compared to this one. Okay, understand? You just follow. Okay, okay. I will explain a little bit more on phasor diagram later on, but for this part, I think this one is enough. So if they give you about the time dependence, most likely this is the question that they might ask. So dia tak susah sangat, and biasanya maka dia pun tak ada banyak sangat pun. So I suspect they might ask this question like in part A. The part B they might ask about circuit, and part C the different one. Okay. And just a reminder, this topic consists of 10%. 10 marks out of 80. So that one is about 13% kot. 10%. And divided by 80, it's about 12.5% chapter ni. Tapi senang nak score. So, selain daripada chapter quantization of light ataupun chapter photoelectric effect tu, chapter ni saya punya second favorite chapter lah. Sebab senang. Okay. So kalau dia tak tanya in this form, in graph form, they might ask you in terms of circuit. Okay. So in terms of circuit, it doesn't mean that they will give you a circuit. Sometimes dia tak kasih circuit pun, but instead dia tulis dalam sentence. So what you gonna need to do is that you have to draw the circuit lah. So circuit ni ada dua type. Satu kalau dia consists of single component. Another one is consists of multiple component. Okay, example for single component. Let's see if you have a circuit with a resistor. Okay, it could be just a resistor, or just the inductor, or just the capacitor. Any one of these, satu je. So if you have only one, you can use the formula of V equals to IRMS. So it's VRMS, IRMS. So this one, you could use R. Okay, or you can write this one. Itu kalau circuit dia consist of R lah. Kalau dia adalah inductance, hanya ada inductor, then you can write this one as XL. Jadi kalau kamu buat single component, so you can write this and this. And in fact, VRMS is equals to VR. VRMS is equals to XL. Make sense lah. So dari satu komponen je. Okay. And then for multiple component, so the istilah combination lah. Let's see if I draw here is combination of 3. Okay, so this is an example of RLC. It could be RLC, it could be RL, or it could be RC. Okay, the moment they check out and this one is multiple component, you have to use VRMS, IRMS. Now the partner would be Z. Okay. Are you guys follow me? Are you guys still with me?
Yes, yes.
Yeah, yeah, that's it. Okay. So the Z here is equals to square root of R square plus XL minus XC square. Okay. And for some reason, students selalu terlupa kira yang 2 tu. Okay. So this is the formula that they put inside your formula sheet lah. But at the same time, you can use the same formula, but you can use it in terms of V. So V RMS equals to V R square. Okay, this one is not inside your formula sheet, but you can use it. Okay. The main things that I want to point out is this one. If you have multiple components, straight away you can only use Z. Remember this. This is very important. Okay? So you cannot use this one anymore. Okay? Habit. Student want to write V equals to IR. Tapi kalau kamu pakai Z here, becomes wrong lah. Salah. Okay, so all of this actually translate into a phase diagram. So I'm going to detail a little bit about phase diagram. Phase diagram, you only have to draw the one that have lah with the component that you have. So kalau semua komponen ada, kalau RLC, basically you have to draw it like this. Okay. This one is your, ni apa ni kat atas ni? Kalau saya nak label in terms of Z. Atas tu apa? Atas arrow tu. Ya, saya tunjuk, saya suka kamu ingat apa? Langit, cacing, tanah.
Cacing je.
Cacing kat atas, okay. Cacing kat atas, you sure? Apa yang kat atas? Cuba kamu tengok atas, kamu nampak apa?
R. Langit.
Langit R ke? Macam mana kau measure langit? R-A-N. So, XL dekat atas, R dekat tengah, cacing kat bawah. Dia saya tak pernah nampak gila cacing terbang. Tu orang macam ni. Alternatively, sama macam equation tadi, you can use this one as my VL. You can write this one in terms of VRMS, IRMS, R I can write as VR, and XC I can write as VC. So you only have to draw the one with the component that you have lah. If you only have R, so lukis ini je lah. So this one jadi VRMS. Kalau ada C ke bawah saja dengan I dia macam tu. Okay, and then I want to point out the angle here. The phase angle is what we call phase angle lah. Okay, dia sebenarnya adalah angle between VRMS and what's wrong with this IRMS. So it is an angle between VRMS and IRMS. So this one will state whether VRMS leads or IRMS leads. So if you are looking at the formula, the tangent theta equals to XL minus XC divided by Z. Okay. Alternatively, the one that is not inside the formula, you can use cos phi equals to R over Z. Okay. Remember that the phi is the phase angle, but the cos phi actually represent the power factor. Okay, power factor is actually one of the quantities that determine how effective and how effective is the application. Contohnya, if you have light bulbs, you have power factor close to 1, that means all the power supply is being changed into power output. Contohnya, so the closer to 1, highly effective it is the application. Okay, siapa pula video plan dia tekan kan? Okay, alternatively, you can use tangent phi lah. But this one is power factor, phi is the phase angle. Again, from the phasor diagram, the direction of omega is in this direction. Remember that. Sometimes they might ask you to draw the phasor diagram lah. You just label like this. Okay, so far any question? Kalau tak ada, kita move on to the next one. Okay, the next one is about, before we go to into power, I want to touch a little bit about resonance frequency. Resonance frequency ni sometimes memang sebut dalam exam lah, sebut dalam soalan resonance frequency. So you know that this one is resonance frequency. But sometimes dia tak cakap directly. So one of the main conditions for resonance frequency is when XL equals to XC. It comes from a graph of Z impedance against frequency. Okay, you have XL this, you have XC that looks like this, and then you have the resistance R like that, and the Z is over here, should touch the graph. So XL is equals to XC is over here. So basically this is your resonance frequency punya values. And then from XL equals to XC, you can see that Z minimum is equals to R. It is touching. Okay. So once you have that, if you guys still remember, our cos phi power factor is equals to R over Z. So kalau R equals to Z, that means this one is equals to 1. So at resonance frequency, this is at optimum apa? Efficiency. Ayo. Okay. Saya akan write this one. So normally they will ask you to calculate FR lah. Ataupun sometimes they give you different wording like find the frequency when Z is minimum. So that one is at the resonance frequency. Dia tak sebut pun resonance frequency, tapi kamu kena tahu lah. That one is at resonance frequency. And then kita sebut pasal efficiency. So the last part is about power. Power ni biasanya the last questions lah. And sometimes dia tanya, sometimes dia tak tanya. So power can be divided into two. P instantaneous which is equals to I in terms of time multiply with V in terms of time. Maksudnya kamu kena cari current at specific time multiply with voltage at specific time. For P instantaneous, this one is seldom that they ask. Jarang tanya sebab kamu jarang diberi I dengan V untuk specific time. Melainkan yang asalnya ditanya pasal time dependence question tadi, this is the follow up question. Okay. Another one you have is P average. The actual formula inside your formula sheet will be P RMS, I RMS, V RMS, cos phi. And the cos phi over here pun sama level hantu dia tu macam yang square tadi. Square ni kan, student selalu lupa, cos phi ni pun sama. Student selalu lupa for some reason, I don't know why. So my suggestion is that instead of using this formula, I strongly suggest you to use I squared R. Okay, because it's much safer and guarantee you can get the answer. You don't have to calculate the cost fee. Okay, so my suggestion for you to use this one. If you use IV, if you only want to use IV only, make sure this one is VR, which is very unlikely kamu ada that information. Okay, so ada soal?
Sir,
Any question?
nak tengok yang previous slide je. Nak. Tak bisa salin.
Okay. This one. Okay.
Okey. Sekejap.
Okay, tak tahu. Okay, yang lain ada soalan? Yang mana? Dah hilang lah.
Tak ada sir.
Okay, for dah ada balik lah. Okay, for those yang tak ada soalan, kamu boleh
Okay,
buka
sir.
question pasir soalan nombor 8. Okay, can try to read the question first. Soalan dalam buku tutorial. Question C is one. Question number 8 dari A, B and C. Dah baca belum soalannya? Okay, for question number 8, they give you a circle and they label over here with 100 ohms, and then you have V equals to 200 sine omega t. Okay, it shows AC source with voltage of V 200 sine omega t connected to 100 ohm resistor. Calculate the RMS voltage, RMS current in the resistor and average power. Okay, so we focus on question 1, 2 and 3. RMS voltage kita nak represent dengan simbol apa?
BRMS.
Okay, good. Sempat je lah RMS. For RMS current?
IRMS.
Girl mana? Girl hilang terus. Look. RMS. Okay, good. Girl selepas ambil gambar dia tidur dulu. Okay, and then average power, simbol apa kita nak pakai? PAVE.
P average.
Okay? Alright, good. Okay, so 100 ohm itu kita nak represent dengan apa? Simbol apa?
Apa soalan?
100 ohms tu kamu nak wakilkan dia dengan simbol apa?
R saya R.
Okay. So you have V equals to 200 sine omega t. So they give you function. Okay. So the 200 over here represent apa?
V not.
Yes. Okay. Macam mana kamu tahu dia adalah V naught? You can compare with the general equation, which is V equals to V naught sine omega t. So straight away you know that V naught is equals to 200 volt. Okay. So question number 1, they want you to find RMS voltage. Apakah formula apa? Can use V naught over square root
V
of
not over
2.
square root of 2.
We should calculate. So open. Okay, if you get a different answer. Ada manis. Kalau dapat jawapan lain cakap saya ya. Good, very good. RMS. So, saya nak try. Cik, apa kaitan V nak Macam mana saya nak katakan V nak
Pakai VRMS over R.
Okay, RMS. Okay. Betul kot. Okay, you can use the Ohm's law. Okay, tapi setiap kali kamu nak tulis, tanya diri kamu lah. Dekat sini kamu nak tulis apa? R ke XR ke XC ke Z? Kau tulis apa ni? Kat sini.
XC.
Ha?
XZ.
Z. Okay, kalau kamu pakai Z tu, kalau dia ada more than one pen, maksudnya ada lebih daripada satu. Sekarang ada berapa? Ada satu ke lebih?
Satu je.
Kalau satu, apa yang ada?
XC.
Gambar dia
Aku
satu
tak tahu.
sikit. Gambar dia agak meragukan, tapi dia sebenarnya ada register. Dia adalah R sebenarnya. Okay, satu kita tulis kat atas pun R. Register. Kalau confuse dengan gambar ni, kena baca ayat dia kot. Ayat dia register. So kalau register, single, dia adalah R. Kalau inductor, single, XL. Kalau kapasitor, XC. Okay. So now, IRMS equals to VRMS divided by
R.
100. Okay, good. Which is 1.41 ampere. And then the last question, they ask you to find the P average. Kamu nak pakai formula apa?
IRMS times VRMS.
Times apa?
VRMS. Ke? Tak tahu.
Itu je.
Tu je. Kot.
Times R. Yang
Ah.
XC dulu.
Okay, kalau kita tengok balik yang saya tunjuk tadi kan. Just now, kalau ikut formula sheet, dia ada formula ni. Tapi jangan terlupa cos phi ni. So you can use this formula as long as you use cos phi. Kalau tak ada cos phi, you can use this one, make sure this one is phi R. Tapi nak selamat, suggestion saya pakai lah ini. Dia jadi I squared. Okay, saya akan pakai I squared lah. So it will be 1.41 square multiplied with 100. I've got 198.81. Okay. If you take like
Betul,
3
sir.
decimal place, if you take 3 decimal place, obviously you get a different answer lah, but it should be okay. Okay, any question?
Tak ada, sir.
Tak ada. Okay, saya rasa soalan A ni, the only constant will be the power. Okay, power ni student biasalah dia traumatize sikit. Tapi kalau kamu pakai formula ni, dia sepatutnya tak ada masalah pun. The average is I squared R. Simple as that. Okay. Moving on to the next question, which is question B. Get C or AB. Okay. B, a series of RLC circuit consisting of 35 millihenry, 45 microfarad, 55 ohm, AC generator. Okay. Ini circuit apa? Apa nama circuit ni? Dari berapa banyak komponen?
Multiple.
Multiple. Okay. Berapa tu BZ? Satu, dah tak ada lah. Dua ke, tiga, empat ke, lima?
3.
Iya apa? Ini cakap awak ni, tak dengar. Macam terputus.
3 kan, sir?
Sir, line saya
ada
tak
3.
okey.
Oh. Okay. Nanti
Sekat-sekat.
kamu dengar tak saya cakap?
Dengar, tapi kadang sekat-sekat.
Tak dengar. Tak ada. Okay. Dia adalah RSC circuit. Memang dia tulis dalam soalan. RSC circuit. RSC maksudnya ada resistor, ada inductor, ada capacitor. And the circuit should look something like this. Tadi saya lukis. Okay. It look something like this. So I'm going to copy this one. Semangat nak balik. Okay, so I strongly suggest you to do similar step like me lah. You draw the circuit first, and then you take out the information and write it on the circuit itself. So 35 millihenry itu dia punya apa? 35 ni dia punya apa? Simbol apa kita nak pakai? Tulis 35. Ha? Kita pergi depan sikit.
Boleh M ke, sir?
Simbol L.
L. Really? So this is your L. Okay. 45?
P.
Okay, capacitance is
C, sir.
Capacitance. And then we have R equals to 85 ohm. Okay. So 150 volt. Biasa saya tulis kat sini lah. The frequency equals to 60 Hz. Okay, my question is, V ni V apa? Simbol apa kita nak pakai?
V besar ke, sir? VRMS.
Betul. VRMS to be exact. Okay. So this one would be VRMS. So for this chapter, kalau dikata V supply, dikata V in the circuit, kalau dia tak cakap apa-apa pun, dikata V, itu adalah VRMS. Kalau dikata V across resistor, V across capacitor, that was VC, VR. Kalau dikata V maximum, V peak, itu adalah V0. Okay. Other than that was VRMS. Okay. So most dia adalah VRMS lah. Question number 1. Dia nak kira apa? positive reactance, simbol dia apa?
Xil. Dengan
XC.
2 pi XC.
Okey, betul. Perfect. Dalam induktif induced reactance, simbol apa nak cari?
L.
L ke XL?
Ada XL.
XL. Okay. Impedance?
R.
Apa? Haven't cakap apa? Dengar.
Z.
Kamu jangan celik-celik dengar Dia lain.
Dengar saya dengar.
Okay, impedance nak pakai simbol apa? Kawan.
Z.
Z, sir.
Z, okay, good. First angle?
Yang V.
P, okay, good. Alright. So, kenapa saya nak kamu tulis semua ni dalam bentuk simbol? Sebab saya nak senang bila kamu tengok list of formula tu. Okay. So, we try to solve number 1. XC, macam Holly cakap tadi, adalah 1 over 2 pi FC. So, all the information is given. C dia apa? C dia 45. Mak tamat lah. Forty-five microfarad. So calculate. Dia buat apa tu? Dah hilang semua. Dia buat apa ni?
58.95.
Okay. 5.95. Unit dia apa?
Oh,
Oh, okay, good. Okay, and then we have 2 pi FL. Our L is actually equals to 35. Mana saya tengok tu, saya tengok dekat 35 kan. Kamu jangan baca soalan balik. Kamu tengok yang dia aku dah keluarkan ni. Dia tak adalah lama sangat nak buat tu. Saya dapat 13.19. 13.1. Okay, dapat tak?
dapat sama.
Okay, good. Okay, the next question I want to calculate impedance. How do I calculate impedance? Pakai formula apa?
Z square root R. Panjang tu.
That is equals to
Yang Z
square
tu.
minus
Plus
plus ke minus lah?
2 plus.
Saja je. Yes, saja nak tengok. Okay, kira. R kamu adalah 85.
85.
Ramai student dia akan terlupa letak ni. The word square. Cik kira. Ada yang letak tapi tak kira. Did you get the same answer with me? Right, boleh?
Boleh sama sir.
Okay. And then the last question they ask you to find the phase angle. Phase angle you can use cos,
Sir,
you
macam
can
mana
use
saya
tangent.
dapat R?
Sini saya dapat R tu diberi dalam soalan.
Ya,
Ya,
soalan.
85 eh?
Oh, okey.
Okay.
Thank you.
Okay, and then the last question, Saiful, angkat tangan ke? Tak, tekan. Nak message tu, tekan. Okay, the last question you want to find phase angle, which is your phi. Kamu boleh pakai tangent phi, tapi saya nak pakai cos phi, sebab saya dah biasa pakai cos phi. Dalam formula sheet, tangent. So it will be 85 divided by 96.53. Ini adalah cos phi. So your cos phi is equals to 0.88. Okay. So your phi is actually up cos, and it depends on your mode of your calculator. If you use radian, you get answer in radian. If you use degree, you get answer in degree. I use degree, so my answer is this one. Okay. Again, obviously kalau kamu pakai slightly different method, jawapan dia lain. Slightly different decimal point, jawapan dia lain. And then if you use tangent equals to xl minus xc, you will get negative. Phi dia tu dapat negatif, kamu boleh cuba lah. You get negative 29 or negative 28. So kalau dapat negatif tu, macam mana? Kenapa satu tu dapat positif, kenapa satu tu dapat negatif? Apa maksud dia? Okay, katakan so Lucas phasor diagram. Okay. So,
Dia inverted ke sir?
dekat bawah, betul? Dan dekat bawah. So, you will see that the values of XL is 30.90. XL is up here. Kalau XC is 58.95, so this one is bigger than to the one that is pointing up. So, pendek sikit. So, kalau ikut logik, kamu tu Z tu dekat direction mana? Adakah dekat bawah ataupun adakah dekat atas?
Dekat atas je. Dua-dua boleh.
Tak, salah satu je.
Dekat atas je. XL dengan R.
Sebab apa? Sebab biasa dia dekat atas. Kita ni tak macam tu, dia sebenarnya kena tengok XL dengan XC tu mana lagi besar. Kalau XC lagi besar, which is in this case XC lagi besar, so dia kena ikut yang lagi besar tu dekat bawah sebenarnya. So this is your XC. XC is bigger than XL, so your Z is actually down here. Okay, similarly, if you use VL or VC, kamu jangan buat dalam exam dua-dua, satu je. So the phase angle actually represent this angle. Kan? So kalau kamu dapat negatif tadi, masa kamu pakai tangent, the negative means dia sebenarnya kat bawah. Kalau kita pakai R over Z, kita tak ambil pun dia kat atas ke bawah, kita just ambil di R over Z lah. So we got here is positive. So my suggestion is that whenever you calculate the phase angle, Lucas phasor diagram, tulis sama dengan 28.36. Kalau negatif, tulis yang positif pun tak apa. Okay, you should get the full mark. Okay, ada soalan?
Sir,
Aha.
kalau dalam exam kan,
Aha.
buat dua-dua boleh tak sir?
Tangent dengan cos.
Ah,
No, you can only do once. Satu je. Buat pun nak buat dua-dua, sama je.
oh,
Kalau buat dua-dua boleh,
okey.
tapi dua-dua kena betul lah. Kalau satu salah, satu betul, dua-dua salah.
Okey sir.
Okay. Okay, lain ada soalan? Safina, boleh nak tanya?
Apple ada soalan sir.
Full. Siapa nak tanya apa siapa?
Ada.
Okay, kalau tak ada soalan, kita berhenti Google Meet sekarang kat sini. Tapi kamu continue with the rest of the question. If you have any question,